Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here. It's our first video on stratified random sampling. So let's start off remembering what a sample is. Remember, a sample is a smaller group within a population that you conduct your investigation on, and there were two very important things you had to make sure about your sample. Can you remember them? Well, the first is that your sample is representative and unbiased, and the second is it is as large as you can possibly make it. Okay, the one we're focusing on this video is it being representative, and I'll give you an example of why it may have to be representative. Pause the video and double check you can do this question, which is on a previous video on Hegarty Maths. So these are the students he would pull out, okay, and the technique was simple random sampling, and the question was it biased? And the answer was it is likely to be biased, yes, because in this particular scenario you picked 80% girls in your sample and there are only 20% in the population. So we have to think of a strategy where when it is important to divide up your sample into groups, we do so, and that's called stratified random sampling. So can you remember what I said that was? Well, that's when you divide your sample up into the same groups and strata that exist in the population and in the same proportion. And you do it as follows. You get a list of your whole population and work out their key groups. Then what you do is you work out what proportion those groups are in the population, and then you decide on how many you're going to have in your sample based on that proportion. So if there are 38% girls and 62% boys in your entire school and you wanted to do a sample of 100, you'd make sure you had 38 girls and 62 boys. And lastly, you pick from each group at random. So this is the technique I'm going to show you how to do in this video, how to select those numbers. So let's start with an example. So pause the video and have a go. Well, what we've got here is we've got a scenario of 800 students in a school by each year group here. The head teacher wants to do a stratified sample. You're told of the 80 students in his sample, how many from each year group. Right, the first thing you always do is you just check the total. If you add those numbers up, they do indeed add up to 800, which is how many in the population. Now he wants a sample of 80. Now I always like to draw a picture for this to understand what's going on. I draw a little picture as follows. There's a little box there for my sample and a big box for my population. I call that S for sample, and we know we want 80 students in our little sample, and the population I call P, and I know there are 800 students in the population. Now I want to work out how many times bigger is the population than the sample, so I do 800 divided by 80, which gives me 10. That tells me that if I multiply the sample by 10, I get the population, or anything in the population, if I divide it by 10, I would get my sample. So in this case, we've got the amounts in the population. If we want to know how many in each year group, we're going from the population to the sample. Each of these we just divide by 10. So if we divide each of these by 10, it will tell us how many should be in our sample of 80. So let's do that. That would be 22, 14, 20, 10, and 14. And that's our sample. And if you do add those up as a double check, these two add to 36, 56, 66 and 80. They total up to 80, which is the number you're looking for, and you're done. Right, let's have a go at another one. Pause the video, have a go at this. Okay, same thing. Start off by totaling it like that. Then draw this little picture. Okay, and remember, in this case we have 60 students in our sample, and in this case we had 540 students in our population. So we have to work out how much bigger the population is than the sample. We do the following calculation, and when we do that we get 9. So therefore, you know, from going from the sample to the population you multiply by 9, going from the population to the sample you divide by 9. Here we've got the numbers in the population. We want to find how many in the sample. Each of these numbers we divide by 9. So most of these should be easy for us. 18 divided by 9 is 2, so 180 divided by 9 is 20, 90 divided by 9 is 10, 72 divided by 9 is 8, 54 divided by 9 is 6. We may have to, because this would be a non-calculator, let's say, do that division. 9 into 14 goes 1 time, remainder 5, 9 into 54 goes 6. So there you go, we have worked out how many from each year group in our sample. Let's just add these up and check they add to 60. That is 36, 46, 54 and 60, we know we've done it right and we're done. Right, next one. Pause the video, have a go, but this time you can use a calculator. Okay, always start by totaling. So you've got 540 here. Then start by drawing your picture. You know that in your sample you want 60, in your population is 540. You work out how much bigger the population is than the sample and you get it's 9. So you know we're moving from the sample to population, you multiply by 9. Moving from the population to the sample, you divide by 9. So each of these we need to divide by 9. Now these aren't going to be whole number answers, and this is where you're allowed to use your calculator. So I'm going to get the calculator out and work out each of these. Okay, having done that, you'll notice a problem. They are not whole numbers, they are decimal numbers. So we should round these because you can't have 20.1 people from year 7 in your survey. So let's round as appropriate. This one let's round down to 20, this one round up to 16, this one round up to 10, this one round down to 8, and this one round up to 6. And when you do that, you must check these add up to 60. Sometimes the rounding might make you add up to something other than your sample where you'd have to do an adjustment. So double check, that's the 36, 46, 54 and 60, you're done. So these are your sample and you're done. Okay, next one. Pause, have a go. So the CEO wants to do a stratified sample of 250 people from the 5 divisions. So step 1, you add up to find out how many people in the company in total, and you get as follows. Then you're going to draw our little picture to get an understanding of what's going on. We want 250 people in the sample. We know that there are 2,558 people in the population. You work out how much bigger the population is than the sample by doing this calculation here. But I fear this won't be a whole number. If we do 2558 over 250, yes, it's not a whole number. The calculator simplifies it to 1279 over 125. So let's write that down there, 1279 over 125. Now in the case where it's not a whole number, please leave it as a fraction. It makes life so much easier. So if you're going from sample to population, you're multiplying by 1279 over 125, or if you're going from population to sample, you're dividing by 1279 over 125. So these are the numbers in the population. We're going to divide each of them by this here. So I'm not going to write it all out, but I'm just going to show you that each of these are going to be divided by that fraction. Let me show you how to do the first one, and then afterwards I'll just run through the others. You would do 472 divided by, and then you would type the fraction button, 1279 over 125, like that. Okay, and in this case I get 46.13 if I round to 2 dp, so let's write that down, 46.13. Now if I want to get the next one, I could just press back like that and change the 472 to 846, and in this case here I get 82.68, and so I will continue. Now obviously I need to round after all this because I can't have decimals of people, so I'm going to round each of these. Let's round that down to 46, let's round that up to 83, this one up to 11, this one up to 105, and this one down to 5. Now before I go on, I've got to check they add up to the 250 I want in my sample, otherwise I'm going to have to make an adjustment to one of them. And hey presto, 250, spot on, they are my numbers in my sample. And I'm done. Right, next one. Pause, have a go at this. Okay, just as before, same scenario here. It seems almost identical. You work out how many people in the population. You then draw your little picture, and you want 250 people in your sample, but this time in your population there are 2,530. You work out how much bigger the population is by doing this calculation here. You get your calculator out and see if that simplifies at all. I fear again that's not going to be a whole number, and the calculator just leaves it like that, 253 over 25. So you complete your little picture here. So these are the numbers in your population, so each of these must be divided by 253 over 25. So I'm just going to do that on the calculator and fill in these numbers here. So as before, let's round these. I'm going to round that to 47, that down to 83, that up to 9, that down to 106, and that up to 6. Now just before I race on, I should double check that they add up to the 250, because if they don't, then my sample would be wrong. I only want 250 in my sample. So if I do a check on this, I actually get that they add up to 251, and that's why we're doing this example. What do you do in this case? So I look through these and see which one I had to round the most. These two are quite close. The rounding wasn't much there. In these cases here, the rounding was a bit more, and in this case in particular, the rounding was the most, so I rounded it up there. What if I change that 9 to an 8, 1 down, and then these numbers will add up to my sample size of 250, and I'm done. So it's really important at the end to always double check that and make an adjustment if needed. That's it for this video. Thanks for watching.